Welcome everybody back to Qt Desktop Days. Our next presentation is an old friend of mine. He is from a company called Froglogic, and he has been with them for 15 years. That's pretty amazing. I promised myself I would do my very best in pronouncing his name. I succeeded in the rehearsal room, so and then I'm sure I'll fail now. So he allowed me to call him Susan. So I'll call him Susan for the rest of this presentation. Over to you, Susan.
All right. Hi, everyone. Thanks for having me. And thanks for this kind introduction, Jesper. Right. I'd like to talk about software quality. In particular, I would like to demonstrate an approach to testing Qt applications, which yields really reliable and maintainable tests. But first of all, let me introduce myself. My name is Frerich Rabe. I'm, as Jesper mentioned, a software engineer at Froglogic for almost 15 years now. A major part of that time was spent on topics such as GUI test automation or test coverage analysis or code coverage and things like that. So in general, I work on improving and measuring software quality. So with that out of the way, let's be a little bit more specific about today's topic. I'm going to demonstrate and talk about functional behavior-driven GUI test automation of Qt applications using Squish. Now that's quite a mouthful, I admit, and it may give rise to questions such as what does it even mean to do functional GUI test automation? What does functional mean here? And what does it mean to do behavior-driven testing? That may not seem familiar to you. And finally, what is Squish? And how does it even help with all of this? So before I go ahead and demonstrate it in practice, I think it makes sense to set the stage and address these questions. First of all, what's functional GUI test automation? As you're probably all well aware, Qt is an incredibly powerful technology. And it comes as no surprise that people are making use of all that power, creating very sophisticated and feature-rich applications running on all different platforms and operating systems. But as the feature set of applications grows and they offer more and more functionality, the complexity of the user interface grows. There's more and more functionality which needs to be exposed through the user interface. At the same time, people want to maintain a certain level of software quality. And so they need to have a way to measure software quality. And the simplest approach to measure the quality of your software is just by trying it. So you end up doing manual testing. And the idea with manual testing is that you ideally have some idea of which use cases you want to try. And then you follow manually a sequence of steps, and then again manually verify that the user interface behaves as expected. So in practice, you may have a spreadsheet of some sort saying things like click here, enter that, drag that slider, and so on and so on. And eventually you are supposed to verify that indeed a button is disabled or the right thing is shown. This doesn't only sound very boring, it's indeed quite dull in practice, and it's also quite tedious. One of the main issues with manual testing is that it's very slow. So going through this list of interactions and performing everything manually and then verifying everything manually is very slow, which means that you don't do it as often. So it's not uncommon to see that people do manual testing maybe once a month or even just shortly before release. And because manual testing isn't done as often, it means that more time elapses between introducing a defect into your application and noticing the defect when doing the testing. And since so much time elapses, there's a wide range of changes in the application which may have been responsible for the defect. So that means that debugging issues found during manual testing is typically quite expensive, since there's a wide range of potential issues. This means that for non-trivial user interfaces, manual testing doesn't really scale. And that's where the automation part kicks in. Automation is what makes testing scale. The idea with automation is that you manage to express the sequence of interactions to be applied to a user interface, as well as the expected outcome, in a way which can be processed by a software tool. And the software tool can then automatically drive your user interface and automatically verify that it behaves as expected. One of the main benefits is that this is a lot faster. In fact, with automatically executed tests, it suddenly becomes viable to run your tests like every night, or maybe even on every new build of your application. And since you run your tests much more often, less time elapses between introducing a defect and the test noticing the issue. So typically, it's a lot cheaper to fix issues found during automatic testing. However, test automation also comes with challenges, of course. And one of them is that you need a robust way of expressing the set of desired interactions. So you need a good way of telling the software tool what to do. And this is where the functional part comes in. Functional testing is what makes your test robust and portable. The idea behind functional testing is that you don't really concentrate on the visual appearance of your application, but you rather concentrate on the functionality of it. To give an example, in a functional test, you don't really concern yourself that a certain OK button is pixel perfect, but instead you make sure that it's enabled in just the right moments and that clicking it does the right thing. So functional testing abstracts away the specific rendering of the application and concentrates on the functionality. So next is behavior-driven. What does it mean to do something behavior-driven? One of the core ideas in behavior-driven development in general and behavior-driven testing in particular is that you describe a test or a task in terms of what the application should do, not how. In the case of a user interface, this could mean that you describe that it should be possible to create a new document, but you don't say how that is done, whether it's a button or a menu item or a toolbar button or anything like that. So you abstract away the implementation of the user interface and just concentrate on the desired behavior. This permits, among other things, to create your tests very early on. In fact, if you abstract away the specific implementation of the user interface, you can start creating tests even before the user interface is written, just by describing how the application should behave. And typically, at such an early stage, you involve domain experts, because domain experts know how the application is meant to behave. Usually, domain experts aren't terribly technical people, but they are very familiar with how the application you're developing is going to be used eventually. So their input is invaluable when it comes to making sure that the tests you're writing actually make sense and test sensible behavior. To make collaboration possible with domain experts, BDD tests typically are written in a almost plain text English format following a certain loose structure. So you have a domain-specific language which fosters collaboration, and it typically looks something like this, shown on the slide. In this document, we describe a certain feature, namely registering attendees, and we say that there are given, when, and then steps. The given steps establish the precondition, the when steps describe what is done to the application, and the then steps describe what the expected outcome is. So given there is a registered attendee with the email address so-and-so, when a user tries to register with the same email address, then the registration attempt should get rejected. And this is a very abstract description of how the application should behave. Whether it actually makes sense, that's something for a domain expert to judge, because maybe the registration attempt should not get rejected. Maybe it should be permitted, or it should get merged or something like that. And what's noteworthy about this description is that we don't talk about the user interface at all. So we don't even specify whether we are talking about a web user interface or a Windows application or anything like that. It's just the desired behavior. Finally, what is Squish? Squish is a cross-platform tool for functional GUI test automation. So it's a software tool which is used to create and run tests on other applications. In particular, Squish has a dedicated support for Qt applications, both QWidgets as well as QML-based applications running on embedded mobile desktop and any operating system. So Squish basically runs wherever your Qt application is running. What's noteworthy is that Squish has built-in support for behavior-driven testing, which means that in order to process behavior-driven documents like the one we saw on the earlier slide, you don't need to build your own framework on top, but instead you can leverage the features which are built into the tool right away. To put things into perspective, Squish was first released in 2003, so a little bit more than 17 years ago. And by now it's used by thousands of customers worldwide in all industries. In particular, the Qt company itself is using Squish for testing their Qt Creator tool, among other things. Right. So now we have an initial idea of what functional testing means, what behavior-driven means, and what Squish is all about. Let's see it in practice. So I will switch over to a live demonstration. Let me minimize my presentation and fire up Squish. What you see on the screen now is Squish, in particular the Squish IDE, which is typically the environment you would be using for creating your tests. Now, if I want to demonstrate a GUI testing tool, obviously I need some application to test. And for the purpose of this demonstration, I Googled a little bit and found a nice open source 3D modeling application called OpenSCAD. So this small window is the OpenSCAD window right after starting. And it has a couple of buttons for creating new documents, opening existing documents, and so on. But it also allows quick access to recent documents here. So let's pick one of them and open it. And then you can see a larger image showing up. And in this larger image, you can see an OpenGL control in the top right corner. I hope that's somewhat visible. You can rotate it as you want. And on the left-hand side, you can see code written in a proprietary language, which describes the scene to be rendered. Finally, in the bottom right corner, you can see a console window, which displays messages which are generated while rendering the scene. So I can now go ahead and change this document too. And let's say, change open to Qt, and SCAD means desktop days. And now I can press this button in the toolbar up here, and it generates a preview. So let me scroll out a little bit. You can see it says Qt desktop days. Well, it's not exactly pretty. What can I say? Graphic design is my passion. So this is the OpenSCAD application we want to test. And by the way, this application is totally unmodified. So I just downloaded it from the internet. It's not a debug build or anything like that, which is very important because you want to run your tests on exactly the same build of your Qt application as the one you're deploying to a customer. So now we know what OpenSCAD looks like. And this preview functionality is something we may want to tackle as part of a functional GUI test. So let's go ahead and do that. Back in the Squish IDE, I will jump to the workspace and start by creating a new test suite. So I click this button and I pick a name like OpenSCAD 1, 2, 3, 4. And then I get to choose between different GUI technologies used by the application under test. In this case, it's a Qt application, so I will go with that. Next, I can choose between different popular scripting languages to be used for automating my test. I will just go for Python here. And finally, I can select the application to test. You can see that I already did this with a couple of other applications. I will just pick the OpenSCAD application. Right, let's finish it. And now we have an empty test suite. Next, we need to create a test case in this test suite. And I'll call it something like previews, because this test case is about generating previews. And at this point, you would typically sit down with a domain expert and write the English document. As I mentioned, it follows a certain structure, and it looks something like this. So the feature to test could be rendering previews. And each feature should ideally get a little description. This is not important for running the test, but it serves as some documentation. Remember that you're sitting next to a domain expert. So the description of this feature could be something like, the application permits rendering low quality previews of the entered code to provide quick feedback on code changes, like this. Next, Each feature is divided into scenarios. The idea being that one and the same feature can be executed in different situations. In the case of rendering previews, imagine that you're trying to create a preview of an empty document, or imagine trying to create a preview of a very large document. So you're exercising the same functionality, but in different situations. And I can address that by writing something like scenario rendering a small red cube. Now we write the steps of which our test consists. And as I mentioned earlier on the slides, these steps are grouped in given, when, then phases. So first, we define the preconditions. Given the application is up and running, and I choose to create a new project, now come the when steps, which describe what I'm doing to the application. In our case, it would be when I enter the code, color is red, cube 10, and I request a preview. And finally, it's the then steps, which describe what the application should do. In this case, it would be then rendering a small red cube is shown like this. Okay, so we now created our very first behavior-driven style test. And even though this mostly looks like English plain text, the fact that I can collapse these and that the lines have some yellow underlining shows that there's a certain structure to the document, and Squish understands this structure. All these yellow lines and the warning icons next to the line numbers mean that Squish cannot actually run this test just yet. All these steps are not implemented yet. What we need to do is to associate each of these steps with a set of interactions to be done to the user interface. And the simplest way to implement the steps like that is by recording. So I can right-click the scenario and say record missing steps. And when doing this, the Squish IDE minimizes and it turns into this control bar, which you can see. So let me record something. Oh, sorry, I did something wrong here. Let me repeat that. So I misclicked. Now you see the control bar in the top right corner, and the OpenSCAD application was launched automatically. And at this point, Squish suspends and requests me to perform the interactions to be done for each of the steps. In this case, the step is given the application is up and running. Luckily, Squish was kind enough to do that for me, so there's nothing to do. So I can just click this button and confirm that the step is implemented. Next step is, and I choose to create a new project. So that's a matter of clicking the new button. I did that now. Now it's entering the code color red cube 10. So let's do color is red, cube is 10. Okay, we did that. And now we should request a preview, which is a matter of clicking this button. And finally, we want to verify that a rendering of a small red cube is shown. So at this point, we don't want to interact with our application directly, but instead we want to verify that it's in the right state. And verifying something is a matter of clicking the verify button. And as you can see, Squish offers all kinds of verifications. Since we want to verify that a red cube is shown, a simple screenshot would be a plausible first start. So I click on screenshot, and now the Squish IDE comes back up and shows me the state of the application as it is right now. Down here, I can see all the objects in my Qt application, all the menus and the menu bar and so on. And I can also see all the actions in each submenu and so on. So the tool knows the object hierarchy of the application. It doesn't just see pixels, it actually dives into the Qt application. And that's what I meant when I said that Squish has dedicated support. Also, for each of the objects at the right-hand side here, you can see all the properties. So you can see that a Q action has a font, an icon text, and so on and so on. Now, I could traverse this object hierarchy and grab a screenshot of that OpenGL rendering widget, but a much simpler way is to use this picking tool. With the picking tool, I can hover over my application and visually select the control I'm interested in. This, again, only works because Squish has dedicated support for Qt applications. So let's click this OpenGL view. And now put a checkbox here. And now Squish goes and takes a screenshot of that control. So it's a little magnified here, but you can see the red cube. Let's give a nice name to this verification, maybe something like a small red cube. Press this button. And right, now we have our verification created, which means that we finished implementing this step. I will click this button to finish the recording. And now the Squish ID comes back up. And as you can see, all the warning icons disappeared. It makes sense to have a look at what the tool did in the background. Let's click on any of those steps, like, and I request a preview. And we can open the script file which implements this step. So what you see here is that for each of the BDD steps we wrote, like when I request a preview, Squish generated a small function, which is called step, which implements that step. In the case of requesting a preview, the step consists of a single click button statement. The step, then a rendering of a small red cube is shown, corresponds to calling this test.vp statement, which is what takes care of the screenshot verification. So it's this script file which ties what the application should do to how it does it. In case the application changes, for example, in case creating a new project is no longer a matter of clicking a push button, but creating a new project is done via the menu bar, you only need to change this script implementation. You don't need to change the description of your BDD test. What's also noteworthy is how Squish addresses objects. For example, when requesting a preview, you can see that there's a click button statement. And the argument to the click button statement is the return value of the wait for object statement. And the wait for object call gets this argument, names.editor_doc_preview_QTool button. But that's just a variable. It has no identifying meaning by itself. It's used to do a lookup in the so-called object map. Click it. And in the object map, each symbolic name you can see up here is mapped to a set of properties which uniquely identifies the object down here. For example, our preview tool button is identified by looking for the object with the text being preview, the type is QTool button, it's unnamed, and the visible property equals 1. Of course, we could use wildcards here and whatnot, but the point is that this kind of object identification is totally independent of how the application looks. For example, this way of identifying the preview button does not specify how large the preview button is, or where it is on the screen, or which font is being used for displaying the text, anything like that. This means that when you build a Qt application and you run it on Windows or on Mac or on Linux, the same object name will always work because we abstracted away the specific visualization of the button. This is a good example of functional GUI testing. So we created a very first scenario, no warning icon shown anymore. Let's try running it. So I can run it by clicking this little play button. And when doing so, Squish will repeat my actions, but a lot faster than I just did. So let's see whether we can actually see anything. You see the OpenSCAD application showing up. Squish clicks the new button, entered the code, clicked the preview, and immediately stopped. So it was quite fast. But for some reason, something failed. Let's see what we've got. We can see that most of the steps actually succeeded. That's why they are green. So the application is up and running, creating a new project worked, entering the code worked, but then the step of verifying that a rendering of a small red cube being shown, that one failed. And down here, we can see some details. Let's see the screenshot differences. So we can select this, and then I have this splitter view in which the left-hand side of the handle shows the expected screen, and the right-hand side shows the actual screen. And we see that we expect a red cube to be shown, but in the actual image, there's no cube there. What's that? Well, that's one of the things with automation. Sometimes you've got to debug stuff. So let's do that. A good way to debug this kind of problem is to put a breakpoint right next to the statement which takes care of the verification, and then run the test. And then we will have the test executed up until that point, and now Squish suspends. So Squish repeated all my actions, but it didn't actually perform the verification. Instead, it suspended test execution and so shows me the state of the application. So let's look at the application under test. But there's a red cube shown. What gives? What we are seeing here is an example of something which makes test automation quite challenging. In this case, the test was executing too quickly. Remember what the test does. It creates a new project, enters the code on the left-hand side, clicks the preview button, and then immediately verifies that the OpenGL view in the top right corner shows the right image. But if you look at the console window, you can see that there's a message saying total rendering time. In this case, it was quite fast. It says total rendering time 0 hours, 0 minutes, and 0 seconds, but still the application needs a little bit to create the rendering. So what we need to do is we need to delay grabbing the screenshot a little bit. We need to delay it until the rendering is actually done. So we need a way to determine that the rendering is done. A good way to do this is by checking the text of the console and then verifying that the text total rendering time is displayed. So let's do that. We will take advantage of the fact that Squish understands the Qt applications. So what we can do is we can select the console window and then inspect all the properties of the console. And one of the properties of the console must be something like text or plain text. Let's see. Plain text, there you go. There's a plain text property. What we could do is we wait until the plain text property holds a certain value. Let's take the symbolic name of this object. And now we augment our step for requesting a preview such that after clicking on the preview button, it waits a little bit. Something like this. Console is wait for object and then this name. So now we've got a handle on the object. Something like console.plainText gives us the plain text of the console window. So we will insert a little statement like wait for. It takes a callable. We'll do wait for total rendering time in the string representation of the plain text of the console. So what we just did is we grabbed a handle to the console control, and then we added a wait for statement, which will repeatedly check and wait until the text total rendering time shows up in the text of the console. This should work because that way, after clicking the toolbar button, we wait a little bit until checking the screenshot. Let's see what happens. So I will stop the test again. Let's run it again. The application starts, Squish clicks on new, enters code, and now everything is green. So now Squish wait a little bit, and we took advantage of the fact that we don't view the application as a set of pixels, but instead we really see discrete objects. Now, as I mentioned, it's common for all features to be exercised in different scenarios. Let's try a different scenario. I will just copy this one and make it prettier. And now we could try a different code. For example, we could try rendering a large green cube, for example. And rendering a large green cube mostly follows the same steps, except that the code we entered different. And a rendering of a large green cube should be shown. Like this. And you can see this time there are just 2 warning icons. And that's because Squish knows that certain steps have already been implemented. Squish knows that choosing to create a new project is a matter of clicking that button because we taught Squish when recording the first scenario. So this time around, it only wonders about these two steps. And as before, we need to fill them with live, but only the missing steps. So as before, we will start recording the scenario. And what Squish does is it repeats my actions, but only until it hits a step where it doesn't know what to do, which is now. So it repeated my actions, it launched the application, and it created a new project. But now it suspends because it doesn't know how to enter the code color green in Cube 20 by itself. So until we are done with our work on AI testing, which makes all this obsolete, I will have to help the tool. Let's enter that code. Okay, I did that. And now requesting a preview, that part Squish already knows, which is why it automatically clicked the toolbar button. But now it suspends again because it doesn't know how to check that there's indeed a large green cube shown. So let's insert a verification here. As before, I will do a screenshot verification because that's simple to understand and not a bad idea in this case. I will pick the OpenGL control and take a screenshot of that. And as before, I will use a nice descriptive name like large green cube. Okay, let's save that. And now we're done and we can click the button again to finish the step. And now we're back in the Squish IDE and you can see that the warning signs disappeared. So let's see what happened behind the scenes. When clicking one of the steps, what's noteworthy is that only these lines are new. Everything above comes from our first scenario. So by using a tool which has built-in support for behavior-driven testing, you automatically get some modularization of your test code. It's not just one big block of script code, but instead it's already split into individual functions and they can be reused by the tool. For example, notice that this time around, we didn't need to tune our function again for rendering, for requesting a preview. Squish automatically reuses our hand-tuned synchronization logic. This makes testing in a BDD style a lot more viable and maintainable because adding new scenarios does not mean adding an entirely new test script, but you also don't give up on the recording functionality. If you were to create a script-based test case, you would have re-recorded the entire sequence from scratch. Now, if you squint a little bit, you can see that there are some steps which look remarkably similar. For example, we have this step when I enter the code color red cube 10, and we have this step when I enter the code color green cube 20, which are basically the same. Both use a mouse click statement to give the focus to a text edit field, and then both use a type statement to enter some code into the text edit. So we'd like to avoid the duplication, of course, and luckily the BDD language built into Squish makes that very easy. So instead of using a plain string, we can also use placeholders, and it works like this. We replace this text and write pipe any pipe, which is a placeholder. And the text, which will be represented by this placeholder, is then passed as an argument to the function. We will call it code. And this argument can then be used in place of the hard-coded string here. Right? And this makes the other step obsolete because now we have a generic step which works for any code. And this further reduces the amount of script code we need to execute our two scenarios. If I go back to the BDD layer, the behavior-driven layer, I can see that jumping to this line, to the script code associated for this step, this function, and the same in the second scenario. So even though it's two different steps, it's the same implementation. And that makes tests a lot more maintainable. Let's give it a try and run both of them immediately after each other. Squish launched the application, clicks the new button, enters some code, and then it immediately launches the application again and does it again with a different code. And we can see everything is green. The application seems to be able to do previews all right. Now, we resolved some code duplication in the script code, but you could argue that there is some duplication between these two scenarios. especially when you have more than just 2 scenarios, it easily happens that you have multiple scenarios in which the same feature is basically used in the same way, except for the fact that some values are different. And this is an example of such a situation. When doing behavior-driven testing, the language which is used typically allows creating something called scenario templates or scenario outlines. And it works something like this. Instead of scenario, we write scenario outline. This caption no longer applies. And then we take the steps and replace those pieces which should be flexible with placeholders like this. When I enter the code, then a rendering of and this should be called rendering, right? So we basically have a template for a scenario, and then we instantiate this template with examples. So we just write a simple ASCII table like this. One code would be color is green and cube 20. This should yield a rendering of a large green cube. And then we will have color is red, cube, what did I use? 10. This should render a small red cube. Okay. Let's align these pipe symbols a little so that it's easier to see that we are just setting up a little table. This table, by the way, doesn't need to be defined in this file. It could also be stored in the external spreadsheet and then included into this file. So now I replace these 2 scenarios with just one scenario outline. And when running the scenario outline, all the steps will be repeated for each of the lines in my examples table. Let's give it a try. Again, the application shows up. This time around, you can see that the first test was for a large green cube, and now it's checking a small red cube. That's because of the order of the rows. This time I had the green cube first and the red cube second. Right. So this gives some first impression of what it's like to do functional behavior-driven GUI test automation for Qt applications using Squish. But to be honest, this is not actually how you run tests with Squish. Turns out that people don't actually sit in front of their IDE and press play all the time, as I just did. Instead, you would like your automated tests to be run as part of your nightly builds, for instance, or as part of your continuous integration system or anything like that. And luckily, this is quite easy with Squish and should be possible with any testing tool you use. On the inside, Squish is just a client-server architecture. So there are 2 programs which are connected using a TCP/IP connection, so they could be running on different computers. And the idea being that one of them is running where the application under test is, and the other one is running where your test scripts are stored. So there could be different operating systems involved. Let's minimize this and give it a try. I go to my Squish installation folder and start the first program called Squish Server. And then I will have a second console and start the client program called Squish Runner. And it takes a couple of arguments, such as where the test suite is stored. What did I call it? Open scat 1, 2, 3, 4. And then we would like an HTML report in this directory. Oh, sorry, not Squish Server, Squish Runner, obviously. And what this does is it makes Squish Runner connect to Squish Server and then executes the test without the IDE being involved. That's also how you can integrate Squish with any kind of automated build infrastructure. But chances are that you don't even need to run these commands directly, because Squish permits, we feature all kinds of existing plugins for tools like CTest, in case you're using CTest, or Jenkins, and so on and so on. Let's have a quick look at the report, what it looks like. The browser, and here you go. Everything green. Okay, all verification passed. Okay, so of course there's a lot more to talk about when doing GUI test automation, but I would like to keep this focused on the desktop and BDD. So I think it's a good moment to go back to our presentation now. If you want to learn more about all this, there are a couple of ways. You can get in touch with us by just sending an email to contact@froglogic.com. If you're interested in behavior-driven development in general, I very much recommend the website bdd.tips, because it has all kinds of information on how to write and structure your behavior-driven documents. The smaller one I just wrote only just touched the surface of what's possible. Finally, if you're interested in Qt GUI test automation, I recommend having a look at Squish at www.froglogic.com/squish. There's even a free trial available, so you can try it out on your own application right away. Right, so we have some time left, and maybe Jesper, you would like to chime in and see whether we have any questions.
I'm on my way in there. There we are. So thank you very much. That was very interesting. We do have a few questions indeed. So the first question is, does this work with application written in PySide too?
Yes, Squish doesn't actually care about the programming languages so much. What's more important is whether it eventually uses the Qt library. And as far as I recall, PySide is just Python bindings for Qt, right? So in principle, this should work just as well.
Okay. You already mentioned the CI. There was a question on that. A follow-up question to CI is, does this require a X server or some visual for it to be able to run?
Yeah, generally it does. And this is not so much a requirement of Squish, but of your application. Typically applications, Qt applications included, require some sort of display to render the user interface to. You don't necessarily need a real X server. Something you could do is running a headless VNC, for example. You don't necessarily need to see it on the screen. You could also use virtual machines if that's appropriate.
Okay, interesting. And a follow-up to that question is if these Squish tests can take quite a while to run, and if you want to run them in your CI after every commit, are there any facilities in Squish for parallelizing a number of tests?
Yes, there are two approaches, and this is actually a very good point. Typically, when people see Squish like this, they think, "Oh, this is a nice idea. Let's do that," and you just keep adding tests and tests and tests, which makes your test execution slower and slower and slower, even though automation is already much faster than manual testing. So you need to have some approach to making the runtime scale. One way is indeed concurrent test execution. This is very easy because the Squish runner command I just showed on the command line, it can be executed in parallel. So you don't necessarily need to run an entire test suite, for example. You can have all test cases run in parallel on different computers. That's one way to approach this. Another way to approach the issue is by identifying which test cases need to be executed in the first place. This is a little bit more involved, and tomorrow my colleague Nicholas is going to talk about it at 6 p.m. Central European Summertime, I believe. The idea being that you combine GUI test automation with code coverage analysis. With our other product, Coco, you can measure the code coverage per test case. So you know for every test case you execute with Squish, which pieces of your application are exercised. That means that when you do a new build of your application, you can consider the code change, the diff, and see which parts of your application changed. And then you start with executing just those tests which are relevant to the source code change. So you don't necessarily need to run all your tests all the time, but instead you can be a little bit smarter about it and make some very educated guesses about which test cases are actually relevant and which aren't.
Seems like I need to be around tomorrow at 6 o'clock too then.
Yeah.
There's a question here on QML. You've shown a widget application as far as I could tell.
Yes.
But how about QML? Does it know properties in QML too?
It's the same thing. It's really the same thing. You see the hierarchy. of QML objects. You can see all the properties of the QML objects. It's really the same thing. Of course, if you've got a highly customized QML applications and you decide to model every single button yourself, the object hierarchy will be a little bit more low level. So you won't have nice button controls or the like. But in principle, it works exactly the same way. The IDE, the scripting language, the picking tool, it's all the same.
Interesting. There's an updated question from the question on the CI. The question is, do you have advice or docs on getting display environment working in CI?
The display environment, yes, we do indeed. There's a knowledge base which we maintain at kb.froglogic.com. And if I remember correctly, there's an entire page or even set of pages dedicated to getting continuous integration up and running with GUI test automation. And topics like how do I manage the display, or what do I do with headless systems and so on, that's exactly the kind of stuff you can find in the knowledge base.
Excellent. Let me just see if I've covered them all here. There is one that is there any option for performance tests in Squish?
You can do that. Something which is not too uncommon is that, for instance, you want to ensure that, taking the OpenSCAD application as an example, a rendering takes no longer than, let's say, 5 seconds. Or you want to make sure that after logging in, the main window shows within a certain amount of time or something like that. So what you can do is you measure the time in your test script between 2 interactions. So you can take a timestamp. After all, it's a full-grown scripting language. You take a timestamp and then you perform some interactions, and then you wait for an object to appear and you measure how long has it been between those 2 points in time. And then you can log a failure or abort the test or whatever seems appropriate to you.
Awesome. I think that was it. I have one question on my own that maybe you can elaborate on just a few seconds here. I was wondering the behavior-driven language that you were writing your test cases in. Yeah. How powerful is that language? I mean, you're showing like you have a very simple if statement in C++. That would be the equivalent. But how powerful is the language as such?
Not very much. Let me just minimize my presentation and open the Squish IDE again. This language is intentionally restricted. The point is that you shouldn't really turn this into a program. So you don't want an if statement. If OS is Windows, if OS is Windows, where's my cursor? Windows, then do this, else do that. So you don't want that. The reason being that these documents are typically also added by non-technical people. So non-technical people, the domain experts, need to verify that this document actually makes sense and your application is plausible at all. So it's intentionally low level. It's a very imperative domain-specific language, but it does have some features like the scenario outline or the example tables. What you can also do is you can load data from external files. So it would be imaginable that you do something like when I enter the code, and then you have some multi-line string here, like this. You can do that. The examples, they can be read from an external file. So you could write something like from test data, code examples, CSV, or something like that. So there are some tricks. But in general, this language, which is fairly common, actually, it's called Gherkin. Write out Gherkin. That's the name of the language. It's used by a couple of tools, and the idea is that you shouldn't try to make it too clever. It should still read like a plain text English document describing the individual features and describing how the features should work in different situations.
Okay. So one of the design goals of many different things is to make simple things simple and complex things possible.
Exactly.
Can I mix this way of writing test cases with the more original Squish way of just recording tests and playing them back?
Yes, you can. So every new test case you create in a test suite can be either a script test case, which is the traditional test case, or a BDD test case. It doesn't need to be in one go. And they can also share code, because remember, on the back end, it's still Python code. So in here, you could have shared function, like request preview, and then you have something like request preview like this. And you could call this shared function also from non-BDD test cases if you like. Since this is Python or even the other scripting languages, you don't need to reinvent the wheel. So if you wanted to have a test which, let's say, sends an email in case rendering takes very long, I'm sure Python has got something like SMTP-lib, for example. If you want to run external processes or query databases, which is also quite common, you can do anything like that. We didn't reinvent the wheel. We said that, oh, you can just embed these existing languages and then provide APIs like click button and wait for object to make GUI testing feasible.
Okay. There's I think you already answered the question, but I had to read through my list here, so I didn't hear it. So there's a question, is the language, this behavior-driven language, is that a standard one or something you invented?
Yes, it is. It's a standard. I wouldn't call it standard, but there are a number of tools which all use the same language. It's called Gherkin. Okay. This is the name of the language. And if you Google for Gherkin BDD or something like that, you will see that there are other tools. There's a very popular tool, I believe it's from the Ruby community, but I may be wrong. It's called Cucumber. So if you go to cucumber.io is the homepage, I seem to recall. That's one of the tools which I believe originated. But then the language was slightly modified every time it was supported by a different tool. And of course, the authentic Squish experience involves slight modifications to the Gherkin language too.
Okay. Thank you very much for your presentation and for
You're welcome.
Brave enough to show us live. And it worked out. So good there. Thank you very much.
Bye. Thank you very much for having me.